Hello, everybody. This is going to be episode 1 of my first series, Flashlight Shoes. As you can see, I have a shoe here. And these are going to be the shoes that I'm going to be using for the actual final build. There's just like a $15 pair of shoes I got from Walmart. Now I can cut them up as much as I want. So this is Sparky here, Sparky Builds. And we're going to be making flashlight shoes. So you know how you have your regular shoes, boring stuff. Nobody wants to use regular shoes, right? And then you have your LED shoes where you have it glowing all around the sides. Good for raves and everything. Very fun, very fun. But what we don't have are flashlight shoes. The idea is headlights for your feet. So just like your car beams headlights, be coming off your feet. Tons of practical uses. You can figure them out yourself. I did try taping flashlights to my feet before and just walking outside at night. It does not make you dizzy, or at least it didn't make me dizzy. So there is definitely a possibility that this might work. So the plan is to make it voice controlled so that when you say flashlight on or light on, kind of like the Human Torch flame on, your flashlight shoes will come on. So this would definitely be a ton of fun, or not. Either way, I plan on building it, and I will show you guys how. So let's get started. Okay, so to actually get started, I decided to go on to CAD to actually get a CAD model of the shoe. Because at first I thought about just drawing a shoe model myself, but I was like, go to CAD, grabcad.com/library, grab any CAD model of a shoe. It'll be way quicker than drawing it myself and actually building out the CAD model for a shoe, because ultimately what shoe didn't matter as long as it was realistic size and shape and everything. So I pick on a shoe, chose Adidas, why not? I pick on the SolidWorks, SLD, PRT, so the part model, download the file, and then that brings me to the that allows me to download the files to go into the SolidWorks model. So here's the SolidWorks model. And as you can see, it's a full-blown shoe already pulled into SolidWorks. So I have a good starting point here to actually build my flashlight shoes in SolidWorks to see how all the electrical components are going to fit inside the shoe. There are these weird little off-hanging parts in there. Ultimately, they don't really matter for my purposes since I'm just trying to see how the electrical components fit. If I really cared, I would try to delete them, because for all intents and purposes, I should be able to. As you can see on this long scroll bar here, it has every single little step that went into making it, so I could find that part and delete it, but I don't really see much point for this situation. So since I have all these different electrical components that I need to put into the shoe, I'm going to need to get I decided to go with an Arduino Nano, because it's just easy to program little microcontroller, and it's really small, really small, as you can see here, 1.7 inches by 0.73 inches. So I pull up this user manual here to actually see the size. That way I can CAD out just a little basic model for it. And once I CAD out the basic model, I'll be able to put it into the shoe. So the Arduino is a pretty useful thing to use in this case for reasons I already mentioned. And as you can see, I'm just putting in the dimensions here. I speeded it up a little bit, so this is kind of an over voice right now, but I speeded it up because it was taking a while to actually go back and forth between the dimensions and the model. Even though it's really just 2 dimensions or 3 dimensions, I should have been able to just memorize it, but I have lizard brain, so don't blame me. So I'm just going to save this as a basic model for our part here, and just imagine this is the Arduino board. This is roughly the shape and size of the Arduino board that would be inside of the shoe. So now I'm just pulling out a SolidWorks model assembly for the shoe, and I just put the shoe in there, and it's weird because it has all these extra little lines, and you see like the Adidas logo popped out and everything, but it's not a big deal. I'll fix that up later. So I pull in the Arduino Nano model board, little basic board I have there, and I'm just trying to come up with the, how I want to move it in there, actually get it into the shoe. So I'm just looking at it here, and I'm just rotating it using the move. And I see I click down on there and I can choose to rotate it. And I'm just trying to rotate it to actually get it to fit into the shoe, see how it would angle in there, trying to get a good look. And I can actually slice it up there using that. And with that, what I'm able to do is only see part of the shoe. So it's a section view. So using the section view, I'm seeing into the shoe, and I can see exactly where the little Arduino Nano board is in there. So that looks pretty good. It looks like it wouldn't interfere too bad with putting your foot in there. So next, I need to get the next component that would be necessary, which would be obviously a 9-volt battery. Well, I chose 9-volt battery just because I'm lazy as crap. And I didn't feel like getting a rechargeable battery or, something smaller. And I was like, 9-volt will probably fit. So using a 9-volt battery, I know to work with the Arduino Nano. Arduino Nano is good for 7 to 12 volts on the input, I believe it is. So 9-volt battery should work perfectly fine. So I'm using this. So as you can see the dimensions here. And I'm just going to start CADing out a 9-volt battery. So I'll choose a top plane just so that it's already, in the kind of right dimension for it. It's the easiest plane to start with in the case of this battery. So I'm just going to put in the dimensions here, allowing me to see how big the battery is in relation to everything else. So it already looks small just from here. So now I can extrude it out to the necessary height. So 48.5 millimeters. So now it's full size. Yeah, it's really at this point, I can put it into the shoe, but I was like, just to make it a little bit more clear what it is, because the Arduino Nano already looks like a flat little box because I'm lazy. So I was like, okay, I can at least put in the terminals on the battery for this. So I'm just going to put in a little circle. I'm not too worried about the exact positioning of it, as long as it's on the center line there. That's good enough for me. So I'm not worried about the positioning or size of those. It's just for looks, mainly, putting in those terminals there, just so that I can easily tell it's a battery by looking at it when I'm actually looking at the assembly. So what I can do here is just offset those to actually make them look more like the little terminals in the battery. Make sure to reverse that, put it on the inside. And then that should be good there. Maybe make it a little bit smaller. Yeah. And then I can extrude that out. Probably going to go maybe 2 millimeters, I'd say. And once I put that out to about 2 millimeters, at that point, the battery is actually technically a little bit too tall. So I need to subtract 2 millimeters from the height of the battery just to make sure that everything is the right size. And this is like the maximum size a 9-volt battery is going to be. So at this point, it's good for me to save it. Just save it as a 9-volt battery, basic model. And then I can pull that into the shoe. So insert the component, 9-volt battery, basic model. And there it is. So now I need to try to actually find a place to put it in the shoe. That way your foot will still be able to get in the shoe and it won't be too uncomfortable. Again, the 9-volt battery is ultimately kind of a placeholder. Realistically, if I were to make this as functional as possible, I would want to use like a rechargeable, like a flat pack type battery that would be less in the way. But for my purposes, 9-volt battery works fine. I just want to get this thing working. You know what I'm saying? So 9-volt battery looks like it can fit there pretty good. It won't get in the way of your foot too much. I'll know for sure once I actually start building it, but that looks fine. So next, I need the voice control modules. So I have this speech recognition, voice recognition module V3 that I found. It's only $28. I was looking at price a little bit when I was trying to find some good voice control modules that work with the Arduino. So this comes with, they have an Arduino library that you can use and everything. So it looks like it's 31 millimeters by 50 millimeters. And here's the manual for it right here that they have on their website and everything. So just scrolling through it just to see if there's actual drawing of the model for this voice control module. So I see the size there again and the parameters. And just scrolling through, looking at all the details here, instructions, Arduino, and then it's a whole bunch of instructions on actually coding the thing. So we will get into all of this later. I'm going to be figuring out as I go, and I'm going to be showing you guys how to actually do it as I figure it out. But it looks like there isn't a model, for dimensions and everything for this. So I just have 2 dimensions, so I'm not sure exactly how thick it is. I just know the length and width. And this is the other voice control module, so the Groove speech recognizer. And I just decided I have 2 shoes. I'm going to have 2 shoes for this thing, so might as well use 2 different voice control modules and see which one works better. So just trying to see, for some reason they have dimensions of 0, 0, 0 for the millimeters, so that's useless to me. So let's look at the schematic PDF and see what that says, and that is for like the pinouts and everything on it, so that's not really what I need right now. And let's look at the wiki next. Yeah, let's look at the wiki and see if that has any information on the dimensions. So looking at the wiki, it has some information on it. Actually, a lot of information on it. That's not bad. And there's the dimensions down there. So size 40 millimeters by 20 millimeters. So it's actually smaller than the other one. So now we have the dimensions for the 2 voice control modules. And I'm just scrolling through seeing everything that they have in there. And, one voice control module. So this one has pre-programmed voice recognition voices and phrases in there, while the other one, you have to program the phrases in yourself. That's one of the main differences between the 2. But anyway, as you can see, I have everything in there. And now it is time to put in the voice control module model. So I'll make a model for both of them. And let's get started with the bigger one, which is the V3 voice recognition module. So I'll, just start a square there, put in the dimensions, and that's actually pretty good. It doesn't look too big, at least not yet. It'll be easier to tell exactly how big it is once we get it put into the shoe. And again, I don't know exactly how thick it is. It looks like 5 millimeters is pretty fair. Just looking at the picture, 5 millimeters might actually be a little bit too big. So I'd rather be a little bit too big on my model than a little bit too small, because I conservative estimates here. So just fill it out the corners, make it look a little bit more like the actual thing, and throw in the mic, or at least a vague model of the mic. So again, I'm not super worried about the exact positioning of it. It looks like it's roughly there in the picture of the actual device. So I'm just going to put it there, fill it off the top. And, that's kind of a representation of the mic on the board. So now I have my first board CAD'd out in a basic model that I can put into the shoe. And you see, again, that's the thing here. You don't need to have it super detailed for all the models. You can if you want, but right now we're just worried about the outer dimensions of everything. So the critical dimensions. And for the critical dimensions, we're only really going to have like 3 for each of these things. So it's going to be a bunch of boxes, essentially, in our case. So the second one here actually looks a lot smaller. But again, like you saw, the dimensions are smaller. So that looks pretty good there. The mic is on the corner for this one, but we'll get into that in a sec. I just go 5 millimeters here as well, because again, it doesn't say how thick it is. So let's throw the mic up in the corner. And for this one, the mic kind of sticks out, but I'm not too worried about the location again, just trying to get it generally where it looks like it is, because they don't have actual drawings for it. So the mic looks like it sticks out about that much. So I decided to go 3 millimeters there, and that is the second board. So for actually throwing the boards into the assembly model here, I might as well just go with the bigger board. Like, I made a CAD model for both in case I want to take a look at it, but for all intents and purposes, the bigger board is the one I'm gonna go with, just for trying to see how everything fits. The smaller board should be able to fit at the exact same spot as the bigger board. The only difference might be just where I cut out a hole in the side of the shoe, because I'm probably going to end up doing that, cut out a hole inside the shoe to actually have the mic stick through. That way it'll be easier for the mic to be able to pick up the voice, because it probably won't pick it up through the fabric of the shoe. So gonna need a hole to stick it out of, but I'm not really gonna CAD that in. I'm not too worried about it. So let's just try to get it lined up here, figure out a spot for it. Going to section off the shoe, that way it's a little bit easier to see. And I don't know if you noticed, but I got rid of all of that extra stuff off screen that was on the shoe. So a lot of those extra lines, you can still see a little bit of the extra lines, but I got rid of the picture of the Adidas logo and all the stuff off to the side and all the weird pictures and stuff on there that were just kind of getting annoying for me, honestly. So I got rid of a lot of that stuff off screen. But anyway, I'm sectioning it off and accidentally cut off the module, but let's try it again. So doing this, it'll be a little bit easier for me to line up where I want the module to go in the shoe. So I'm thinking I'm going to put it on the voice control modules on the inner side of the shoe, kind of like how I have the Arduino modules on the outer side of the shoe. So I'll have one board on each side of the shoe and then the battery in the back, just to kind of have everything evened out. And then the light's ultimately going to be in the front, so there'll be like one thing on each of the four sides, so to speak. So at this point, the voice control module is looking pretty good. It looks like it's in the shoe at a decent spot. It shouldn't get too in the way of your foot there. You see how I kind of just pressed it up against the wall, because there's going to be a hole cut out there for the mic, so I'm not too worried about that. The only thing I'm not really going to draw in here is wires. The wires will just be pressed flush up against the sides of the shoe, so I'm not too worried there. Anyway, the last main thing I need is obviously the high brightness LED. So 350 lumens should be more than bright enough in theory, because like a normal flashlight's only going to be like 300 lumens or 250 or around there. So one of these in each foot should give you ample brightness to see decently far ahead of you. So I got the dimensions pulled up here, that way I can see exactly how big it is for my CAD model. So now I can see how big everything is. It looks like it's pretty decently sized. And yep, just general LED package sizing, 5 watts power consumption, not too bad. Should not be an issue there. And let me just scroll down here and show you. I saw this down here before. You can actually kind of see how bright it is. It shines pretty good on this guy's remote control car there. So should be pretty interesting. And there are 2 colors for it. I got 2 of each color just in case I break some, because I probably will. I might even want to pop the LED off of the little board that it's on, just to try to make it even smaller. That way I can fit in the shoe even easier. So I'll play around with that once we actually get the parts in. But for now, we're just seeing how everything fits. So here's a little baseboard for it that the LED is on. And then we got the secondary circle here that we got to extrude out. And then after this one, let's see, we'll have to subtract the sizes off there, but there we go. Now we actually put the little LED on there. And the LED is, I'm going to put in the dimensions in a second. I'm just looking at it right now. There we go. And then I can extrude that out to the appropriate height. And then I'll be able to fillet it down. And that's just, again, another basic model of the LED package. So now I have a general model of what the actual LED package is going to look like. So I can save that off now. So it's looking pretty good. So let me save that LED basic model. And now I can throw that into the shoe as well. So here we go. And as you can see, it's pretty small, so should be able to get it into the shoe. So let's just try to section this thing off again. That way it'll be a little bit easier to see how I'm going to actually fit it in there. So let's see here, try to get it in there, maybe up here. Yeah, but then your foot's gonna get in the way, so not foot get in the way there. We can put it up there, but we don't really want to cut through the rubber at the front of the shoe. I think that's kind of important. I'm no shoe engineer. Is that what they're called? Shoe engineers? I don't know. But I think that rubber at the front's a little important. So I kind of don't want to cut through that and put an LED there. If you kick something, you break your LED. So let's put it somewhere like here. It'll be angled up a little bit, but that's actually fine since your feet are so low down. Angling it up a little bit might actually be ideal. So let's throw it in there. And let's cut a hole in the shoe. I'm not super worried about the exact location of the hole and the size of the hole. Let's just try to get a general placement for it. That way I can see how it's going to look, generally speaking. So let's offset the cut extrude just to make sure that it's not cutting through the whole shoe, and cut a little slit there for the brightness of the LED to shine out. So it probably won't be quite that big, but this should be fine. So now let's take a look at the LED portion. So let's let this load a little bit. It's trying to save. So here we go. Throwing the LED into the shoe. It's looking pretty good. It looks like that should fit there. And yeah, that's fine. I'm not going to worry about getting it exactly spot on. I'm just trying to see if it's realistic to try to fit everything in here. So everything looks like it should be fine just based off of these general dimensions. And I don't think I'm going to have any problems. I probably will, just because that's how things tend to go. But as it is right now, I should be able to fit everything in, including my foot. So we will see. So next I need to actually draw out the electrical diagrams and see how I'm going to do that, and the code. So I'll probably have 2 separate videos for that. But other than that, it looks like everything is good, everybody. So let's head on to the next video, I guess. So I will need to do the electrical layout next. So thanks everybody for watching. This is my first video ever. I love doing this kind of stuff, and I hope you love watching. So have a good one. Bye.